AP Stats, this is the solution to the second question on the significance test. For the first item, I'm looking for 6 things, as will the AP graders. They're looking for stating parameters and hypotheses correctly, identify the test by name or formula, checking your normal, independent, and random conditions, and then showing your work when calculating the statistic, and then write your conclusion in context. So I'm going to be highlighting some student work. This is a really good solution. So um, the first thing you're going to see is they're defining their parameters, and they're very specific about it. P sub A is going to be the proportion of patients who will survive at least 1 year, and then portion B will be the proportion who will survive at least 1 year. If you're not as specific as that, the AP grader might ding you some points. All right. The next thing you see is they're checking the conditions. So this being proportion, we're going to restate something from the prompt talking about randomness. And then the big item here is recognizing that for the normal condition to be true, that every success and failure is more than 10. So that 25 is the 25 people who survive more than a year, and the 729 is the people, the opposite of that. With independence, you're trying to show that your sample is less than 10% of the population, and so since this covers an entire country, that is clearly identified. Um, for the hypotheses, the null hypothesis is that there is no difference between the two treatments. So we're going to assume that the two proportions are the same. And for the alternative, we're going to assume that that the first group of people have a higher success rate. So here's where this person is going to rename the test. This is a 2-sample z-test for the difference of proportions. And she's recognizing the formula as well. In our video last time, they introduced something called the pooled proportion. And you can see that here where she has on the bottom right-hand corner. It's basically just considering the two samples together as using that for your estimator for the proportion of people who survive after a year. So here's a look at the mechanics. When you plug in your values, your P1 and your P2, it's going to look a lot like this. And this is a formula that you have access to out of your textbook or any other resource. But you should show, plugging the numbers in, your Z value followed directly by your P value. Okay, so to get those actual Z and P values, I advocate using the 84 calculator. So if I press Stat and then go to Test, we are performing a 2-proportion Z-test. And so they're going to want to know several things. They're going to want to know the people who survived from the cardio pump, which is 25, out of the sample size, and the people who survived from CPR, which is 16 out of the sample size. And then our alternative hypothesis is that the second proportion is more than the first. And so when I calculate, I'm going to get a p-value of 0.08. All right, so that's a quick way to find these numbers, and with a time constraint on this test, this is the easiest way to find those numbers. All right, numbers you should wrap up with the conclusion and context. So this person does a really nice job. Since the p-value of 8% is bigger than the significance level of 5, we fail to reject the null. The data does not provide enough evidence at the 5% level of significance to conclude that the survival rate for patients treated with cardio pump is significantly higher than survival rate for the patients treated with CPR. So a big gap that I saw in the test is that students didn't put it in context. They did say that we failed to reject the null, but you have to continue that with what's that mean for the test. I'd like to try to use these sampling distributions to talk about the follow-up questions. The researchers suggest performing a significance test at the 1% level. So they're reducing their level of significance. And so one obvious advantage of that, I guess it'd be a disadvantage, is if I go from a 5% to a 1%, I am reducing my chance for a type 1 error. That's an advantage. So one advantage of reducing from a 5% to a 1%. So this orange region represents the probability of a type 1 error. And if I reduce that to a 1%, then my probability of a type 1 error decreases. So I'm just less likely to do a type 1 error. So the distribution below the orange one is the power of the test. So assuming that the alternative is true, assuming that it's more than 0, then the red area represents the probability I'll find an statistic that has me reject the null hypothesis. And notice what happens if I decrease that to an alpha level. Notice I decrease the power. So that's a disadvantage. So a higher level of significance will give you more sensitivity to reject the null hypothesis. But on the other side of that, it also increases your chance of a type 1 error. So your job as a statistician is to try to find the balance of the two to get that done. Question 3, the researchers would like to replicate this experiment. Describe one change that would increase the power. So I told you one change. If you increase the significance level, you will increase the power, but that also has some disadvantages to it. Another way is to increase the sample size. So let me show you what I mean by that. Here I have a sample size of 10. If I increase that to a sample size of 20, you're going to recognize that your sampling distribution is more compact. So that means that your power is going to increase. So to be more dramatic, if I increase my sample size to 50, my power is a lot higher than before. So to increase power, you either increase the significance level or you can increase the sample size in your experiment.